Welcome to The Explainer. Ever wondered how a forest can just grow back after a massive fire? Or how some places seem to bounce back from anything while others just collapse? Well, today we're digging into the secrets of nature's resilience, and you'll see it has everything to do with our own survival. Just look at these two mangrove forests. On the one hand, you've got this vibrant, thriving world. On the other, a system that's been pushed right to the edge. So, what's the difference maker here? Why can one of these handle a hurricane and bounce right back, while the other one just falls apart? The answer, in one powerful word, is resilience. It's that incredible ability for an ecosystem to absorb a shock and return to its original state. And honestly, understanding how resilience works is the key to this entire explainer. So, how do you build that kind of resilience? Well, it all starts with what you could call nature's insurance policy, variety. Or, if you want to get technical, what scientists call biodiversity. Now, biodiversity isn't just about counting up how many different animals you can see. It's so much deeper than that. It's the total variety of life, and we actually measure it on 3 totally different levels, with each one building on the one before it. What's so cool is how these layers stack up. Way down at the bottom, you have genetic diversity. Think of that as all the different traits inside a single family. Then you've got species diversity. That's all the different families living in one neighborhood. And at the very top, ecosystem diversity, all the different neighborhoods that make up a whole city. Real lasting strength is built from the ground up. So let's just zoom in for a second on those first 2 levels. That genetic diversity, the different abilities and immunities within just one species, is absolutely crucial. But so is species diversity, having a whole bunch of different players in the game. You've got to have both for a community to really be resilient. And this is a perfect and tragic example of what happens when you lose that genetic variety. Back in the 1840s, Ireland was basically growing one type of potato. Genetically, they were all clones. So when a single disease came along, the blight, there was zero resistance. The entire crop was wiped out, causing a horrific famine. But look, the potatoes with diverse genes, some of them were able to survive. And this is what happens during what scientists call a genetic bottleneck. Some disaster hits, the population just plummets, and a huge chunk of that critical genetic diversity is lost for good. The few survivors that make it through have a much smaller gene pool, which leaves the entire population way more vulnerable to the next crisis that comes along. So that variety helps populations survive. But how do they all interact with each other? A healthy ecosystem isn't just sitting there. It has a rhythm. And that rhythm is often set by this timeless, back-and-forth dance between predator and prey. This is the classic example you always hear about. As the number of hares goes up, the lynx have tons of food, right? So their population goes up too. But of course, more lynx means more hares are getting eaten, which makes the hare population drop. And then, with less food to go around, the lynx population follows. It's this beautiful, predictable, repeating cycle. And hey, this isn't just some neat theory. The real-world data proves it. Look at the blue line, the prey. It peaks first. And then, lagging just a little bit behind it, the predator population in yellow follows right along. It's that elegant little lag that tells you the system is in balance. It's healthy. But what happens when that rhythm gets completely shattered? A wildfire, a huge flood, a volcanic eruption. These things don't just mess with the numbers. They can literally wipe the whole slate clean. So how on earth does nature come back from that? Well, it comes back through a process called ecological succession. The best way to think about it is like nature's automatic reboot sequence. It's this predictable series of steps that an ecosystem goes through to rebuild itself, starting from bare ground and working its way all the way back to a complex, mature forest. And there are 2 main flavors of this. You've got primary succession, which is like the ultimate fresh start. It begins on bare rock where nothing lived before, maybe after a brand new volcano forms. But then there's secondary succession. That happens after something like a fire, where the soil's already there. And that soil, well, it gives the recovery process a massive head start. And this is that recovery plan in action. Right after a fire, first you get these tough little pioneer plants and grasses that can grow fast and hold the soil down. Give it a few decades, and shrubs and small trees start to move in. And then maybe 150 years later, or even more, you finally get back to a mature, stable forest, what we call the climax community. It's an incredibly slow process, but it's a reliable march back to health. Okay, so we've looked at how nature builds itself, how it balances itself, and how it heals itself. But what does any of this actually have to do with us? Why should we care about all this complex stuff? Let's make this really personal. What does the health of a forest 1,000 miles away or the biodiversity in a coral reef you'll never see actually have to do with your day-to-day life? The answer is everything, because these systems provide what economists call ecosystem services. These are the countless benefits we get from nature, benefits that sustain our lives and our economies that we often get totally for free. And they basically fall into four big buckets. Provisioning services are the actual stuff we take, like food, fresh water, and wood. Regulating services are the jobs nature does for us, like forests cleaning our air or wetlands preventing floods. Supporting services are the crucial behind-the-scenes work, like bees pollinating our crops. And then you have cultural services, things like recreation, tourism, and scientific discovery. So here's the bottom line. When we disrupt these ecosystems with things like deforestation and overfishing, we aren't just harming some abstract nature. We are actively taking a sledgehammer to our own life support systems. We are crippling the very services that provide our food, clean our air, and stabilize our climate. And that has very, very real economic costs. So at the end of the day, it really all comes down to this. Nature provides these absolutely essential services: clean air, fresh water, food, a stable climate for free. It is a silent investment that props up our entire global economy. The real question isn't whether nature is resilient enough to survive us, it's whether we're wise enough to protect our investment.